My name is David Glasser, and I sort of want to talk about like my year of Meteor, the past, present, and future. So I thought about just doing a okay, I'll do a standard Meteor 101. This is Meteor. Let's spend an hour showing you like all the details of how it works. And you know, if that's what you're looking for, I'm going to do a short version of that. But I'd also recommend like searching online. For example, if you look for Meteor 101, there's a great 80-minute video by my coworker Naomi, where she shows much more in-depth, this is what Meteor is. I thought I wanted to talk about something that I haven't actually seen anyone in our group talk about before, which is not just what is Meteor now, but how has Meteor changed over the time that it's existed, and where's it going in the future? So just as sort of a timeline, here's a brief, egocentric timeline of Meteor. So Meteor was launched publicly April of last year. Oh, I forgot that I was going to put a little timer on so I know what time it is. All right. So Meteor was launched publicly in April of last year. It had been the core team, which was 4 people at the time, had been working on it in sort of private for I think about half a year. Starting when they were doing Y Combinator, where they were trying to build an iPad travel guide called Honeycomb, and they learned 2 things in Y Combinator. One was that they did not want to build an iPad travel guide, and the other thing is that the random little tools that they had built to help them do rapid prototyping of websites and web apps, everyone else at Y Combinator was looking over their shoulders and getting jealous of the fact that they were iterating over what they were trying so much faster than them. They said, well, maybe we should just have that be our company. So at the time there was at the time that Meteor launched, there were 4 folks working on it full time, and that was about a year and a half ago now. And as I said, this is the egocentric, my version of Meteor. I joined the company September of last year, so 5 years after the open source project was released, and now it's 1 year later, and I'm giving this talk. And we're still in what we call preview mode. The Meteor right now is at, I think the current release is 0.6.5.1, and at some point in the future, can't quite put a date on that yet, but hopefully not too far in the future, we're going to get to what we call Meteor 1.0. So I kind of want to talk about like the past and the present and the future. So by the past, I mean, what was Meteor like the day it was announced? Like, what is the idea? What is using Meteor like? So I'll do a little demo of making a Meteor app, looking at the source code, making a few changes to that. And then so for the present, I want to talk about how Meteor has changed over the time that I've been there. Mostly not stuff that I've done personally, but some of that also. But mostly just, okay, well, we had this platform. It was very exciting. People got very excited about it on Hacker News. We got investment, etc. What have we been doing for the past year and a half? So these is sort of give an idea of the sorts of things that we think about, from the day-to-day when we come into work, or, well, also when we're in the shower, or, anytime, but especially when we're at work. And so what we've actually built so far in the past year. And then the next thing is the future. So where are we going? When is Meteor going to get to 1.0? What do we need to do to get there? So just a quick overview, Meteor. So Meteor, as I said, released a year and a half ago, and here's some words that were written on Meteor.com on day one. It's an application platform for the rich client era. So what do I mean by rich clients? 10 years ago, you want to write a web app. How does it work? Well, basically, you go to your browser, you type some address in it, or you click on a link. It sends over HTTP a request to the server. The server does a bunch of calculation. It probably queries a database. It, has some templates. It takes some data from the database and from some calculations, renders the template, sends some HTML to your browser. Your browser shows you the picture of the cat, and then you smile or whatever, and then you click another link, and then it does the whole thing again. But all the interesting stuff is happening on the server, because the server is what's powerful, not your like dinky little PC, and the browser is mostly just showing you pictures, maybe doing like silly little things like JavaScript, like making things blink, or like making small parts of the page appear and disappear. That's not really how you want to make a web app these days. If you launch a web app like this, it's just harder to use. Having to wait for the whole round trip and having everything you do be a full page refresh is just not how apps have started work these days. Starting with Gmail and Google Maps were the first big ones to do this. But Facebook, Twitter, all the big name companies and all the hot new startups are making client-side apps where most of the UI, most of the interaction is happening in JavaScript in your web browser, and the server is mostly just sending the app to you in the first place, sending you the data that gets showed on the screen, and actually doing things, like, running methods that do things like actually, like, calling you the cab if it's your Uber or whatever, or sending an email, writing to the database, and so forth. And to make these, there are a lot of frameworks like inside companies like Google or Facebook or Twitter and so on to make them, but they're all different, and you don't get those if you don't work there. And there's a lot of things out there that solve pieces of this issue in the open source world. Like Angular is a really great toolkit for doing the sort of reactive front-end templates, but it's not really connected to to a protocol to talk to a server backend. You sort of have to build your own JSON API, which isn't that hard to do the simple version of. But as you start needing more and more intricate things, you end up doing a lot of extra work yourself. There's lots of great platforms for making servers. I mean, Rails is starting to retool itself as something that's great at being a JSON API server in addition to a HTML server. Node is pretty good at doing that too. But most of the projects are just trying to solve one piece of the system. And at Meteor, we actually think that web apps are like their actual own thing. A web app is not actually like 7 different things put together. You're building one app, having one sort of integrated system where the pieces actually work well together would be kind of nice. Some of the things we try to do in Meteor, we try to put data on the wire. The HTML rendering, all that stuff happens in your browser. The protocol between the server and the client, we have our own protocol for this called DDP. We'll talk about it a little more later. Mostly just sends specific data as it changes to the client, and the client updates based on that. Meteor has just one language. Now, look, I know people can learn more than one programming language. I think it's great for people to, in their career, learn lots of programming languages. But it's kind of a shame if when you say, I want to write a web app, the first thing you get told is, well, to make a modern interactive web app, you need to start out by learning 2 languages. You need to learn some backend language like Ruby, and you need to learn JavaScript because JavaScript is more or less your only choice in the browser. Now, it's true that you could, if you're using Node, you can only have to learn one language for both sides, use JavaScript on the server and the client. But even so, just what you get from Node and the Node web frameworks is great. I mean, I love Node. I mean, it's what Meteor is built on. But you're still writing very different code in your servers and your clients. Your APIs are completely different. You have to still learn 2 sets of things and figure out how to connect them to each other. In Meteor, we think we should actually have consistent APIs on the client and the server as much as possible, so that you really only have to learn one way of doing things, and so that your client and your server actually work well together and shake hands with each other. We believe in database everywhere. So we have these great APIs for searching for data and changing data. That it's called a database, right? On your server, the way you get your data is by going to a database. On the client, often the way you get your data is you do a JSON query, and then that gives you to some JSON REST endpoint. It gives you a bunch of data. It gives you the 10 documents that match that query back. And then later, I guess you just do that query again, and then you diff them manually, and then you probably actually need to do something with this data. Also, you probably use it to update something on the screen, so you probably just make up some ad hoc data structure to store whatever data you got from the back end, and you keep it up to date. And if you want to do searches on it or changes to it, you sort of write more ad hoc stuff. And it's we actually have come up with good APIs for keeping track of data and changing it and doing searches on it. We should have a database API that's inside the client that lets you, when you have a local cache in your browser of what the server is sending you, have a similar database API. Latency compensation. Latency compensation says when you do an action in your browser, when you click a button, you probably want to see the results of that immediately. You probably don't want to wait for the server to tell you what happened. And since we have a thick client, the client probably has a good idea of what's going to happen. If it's an add a comment button, probably what's going to happen is a comment's going to show up on the screen. Now, maybe the server will say, actually, you're not allowed to do that. Sorry, you don't have permissions to post. Maybe the server will, I don't know, clean up the capitalization on your comment and change it. And that's fine, and Meteor supports that. But in the meantime, it's probably better to show the comment on the screen, maybe with a different style that says this hasn't been fully posted yet, and then wait for it to come back from the server, for the server to say what really happened. You can build this with other systems, but I have not actually seen anything other than Meteor that does as good a job as latency compensation, because doing this actually requires features in sort of all parts of the system stack that I have not really seen other platforms even try to solve. And reactivity. When you're writing a Rails app, your templates that describe what your HTML look like are pretty straightforward, right? You write your HTML, you have some special punctuation that says this part is this variable or this part, loop over this list. It renders it, it sends it over. A lot of the time, though, when you're writing a client-side app, you don't get to do that. You sort of have to write like, okay, here's my data. Let me like build up my HTML by calling a bunch of functions, or maybe I start by rendering a template, but then when data changes, I have to like go find the part of the screen that has that data and change it sort of imperatively. If you're writing like a jQuery widget or something, that's always how those work also. We think you should just be able to write templates like you always used to. Write a template that says what goes there, and when it changes, it's the system's job, it's the framework's job to keep it up to date. Okay, this is all pretty vague, so I'd like to actually just show the example. And this is still and everything I'm about to show was part of the initial release of Meteor, more or less. So let's go to our shell. This is not a shell. And we'll do Meteor create. Well, first thing to mention is there's a tool called Meteor. Meteor, fundamentally, the way we think of it is Meteor has a build tool, a tool called Meteor, and a bunch of packages. And most of the code is in the packages, but the build tool is also part of sort of the special sauce. And let's in fact let's use an example. There's some built-in examples that you can use to sort of give templates for your projects. Let's do the leaderboard example you might recognize from our screencast if you've seen it. All right, and let's run it. You run it just by typing Meteor server running on localhost. Great. So go to it in our browser, and it's a silly little app that has like a list of your favorite scientists, and it says click a player to select, so you can click on any of the scientists. It then changes the color, puts the name down there. It has a button. You click the button, it gives them some points. They stay sorted by score. Pretty simple. And let's see how this works on the inside. So let's just load up the JavaScript console. So part of how this works is we actually have a database style access to this data. So that let me also just show that in addition to what I was showing you, if I have a second tab over here, everything I do is immediately updated on the other side. And this requires basically no special code to make it so that things show up immediately on your own screen, but also on anyone else looking at it. So this data is actually being stored in a MongoDB database. You also notice, though, that there is separate state for which player is selected. That's not stored in the database. So how does this work underneath? Well, it's pretty easy in Meteor usually to like go in the console and see what's going on. So the players are stored in this Meteor.collection called players. And you have basically a database style API on this. So you can do players.find one, say, and it gives you an arbitrary element. So that's Ada Lovelace. And you see the name and score. You don't need to do that sort of query. You can also do a query like I want to search for some player whose score is greater than 60. He won. And that'll find us Claude Shannon's score of 65. And this uses basically, this API is based on the API that Mongo uses natively. So you can write the same code on the server and the client to do these checks. Now, you can also do writes. So let's say I want to update one of them. Let's update Ada Lovelace. So we have her ID here. And we want to set her score to 100 because she's pretty awesome. And there, it updates immediately right on the top. I didn't have to run any okay, go find the part on the screen that her score was written and update it. This screen essentially knows that when the score changes, it has to update. It also moved her to the top. How do we keep track of the local state? We keep track of local state in something called a session, which is an odd name because it makes you think of a session in Rails, which is a server-side thing, but it's actually a client-side thing. Session's actually really simple. It's basically just a dictionary. So I think the key in this app is called selected player. So we type session.get selected player, you see this, which is Claude Shannon's ID, and you can also set it. So if I do session.set selected player to Ada's, then it will highlight her name instead. So it's basically just a dictionary, just a hash, but it is a reactive hash, so when you change it, it will update what you see on the screen. So let's look at what the source looks like. The source is pretty simple. So what do we have? We have a few files. We have a CSS file, which is, it's what makes it look kind of pretty. The one thing that's notable here is that the selected class is what gives the background color of yellow. We got an HTML file, which is actually a template file. So it consists of, it says here's the title, Here's the main body. The body mostly just consists of using the leaderboard template, which is this whole chunk. What's the leaderboard template? Well, we got a div, and then we iterate over players, and what the word players means we'll see when we look at the source file. And for each player, we put in the player template. That's at the bottom here. So the player template is just a div, and that div might have a class selected, which we'll also see how this works in the JavaScript file. So that's what determines if it's yellow or not, and has the name and the score. And then at the bottom, if there's a name that's selected, it puts the name there again. So you remember, like, the name's down there. And there's a button called ink to increment it. And if there's no selected name, I don't know why this doesn't just use an else. Then it tells you to click on a player. And let's look at the source. So the source is in this file leaderboard.js. So there's just a few files in this directory. And this source file runs on both the client and on the server, which is a thing that is relatively unique to Meteor as far as I know. Now, many of your source code will not run on both the client and the server. A lot of them will be specifically about here's the UI that only needs to be on the client, or here's accessing some backend stuff that only needs to run on the server. And if you want to have code that just runs in one place, you just put it in a directory called client or server. But if you want code that's shared between the two, which often you do for things like defining your model, then you just don't put it in the client or server directory. But you can make part of the file only run on one side by doing like if Meteor is client. So there's actually only one line in this file that runs on both, and it's defining the players collection, which we saw in the browser was access to our local, we call it mini Mongo cache of what the server is publishing. On the server, this is actually an object that lets you query an actual Mongo database directly to look at the players collection. Then this whole block is stuff that only runs on the client. So this template.leaderboard.players equals, and we're actually planning to change the syntax to make it a little more clear in a version soon. But what this says is the word players here, where we're doing this, each is like iteration. So when we're iterating over players, well, what does players mean? Well, players means let's return a cursor that is querying the players collection and sorting, descending by score, and if you have two things with the same score, ascending by name, which is just what we saw, right? It's sorted by score going down, and it stays that way too. Selected name is the name of the selected player, and what is it? Well, we just get the selected player session variable, look up in the players database, return the name. This here is the CSS class that makes the thing yellow. So if the selected player's ID, yeah.
Just a quick question.
Sure.
Is the server aware of those templates, or it's not aware of them at all, so you have to put it in the is client?
I think that the way it works now is that the template code only runs on the server, and I think the template symbol or on the client, and the template symbol probably isn't even defined on the server. We are planning at some point, probably not for 1.0, to add server-side rendering back in, because that's one of the nice things you have about using the same language on both sides. You can use the same code to do that, and that's mostly a performance thing to allow you to perhaps get the initial version of the page quicker without having to, while the client is still loading its stuff, and also to support things like search engines and other things that are not running JavaScript. We have a very hacky solution for how you currently support getting your page indexed in Google, which is very slow, so it's not good for interactive use, but it works for search engines because search engines don't care that much if you take a couple seconds for your page to load. But we have not actually implemented server-side rendering yet. Shouldn't be too hard. Like the Airbnb they have a framework that's sort of does about like a fraction of what Meteor does, but similar goals, and they implemented pretty straightforwardly server-side rendering. So we intend to get to that soon.
Thanks.
But yeah, so let's see. So this basically just determines the CSS class. So it's either the word selected, which is a class, or no class at all, depending on whether or not the selected player is the ID of the player that's being rendered right now. And then we just define some event handlers. So when you click the ink button, it takes in the players collection, it updates the selected player by incrementing it by 5, similarly to how we manually typed set Ada's score to 100. And when you click on a player, it sets selected player to the ID. Then there's some server-only code down here, which in this case you wouldn't have in a real app, but this is what puts the initial contents of the data in there. Yeah. So one question is, okay, so how do you control what data gets shown to the player or to the user? So going back to the shell, I think I mentioned before that Meteor is like a collection of packages plus a build tool. So what are the packages? Well, if you type Meteor list, it shows you all of the built-in packages that you can choose to add or remove from your app. And if you type Meteor list -- using, it actually tells you what's in your app right now. So by default, apps have a package called standard app packages, which is kind of a meta package that includes a bunch of other things that basically says, okay, the standard, like, you just watch a screencast, you want to start prototyping with a Meteor app, packages, what packages are necessary. So by default you want to have a Mongo backend, so the standard app packages pulls that in. It pulls in the templating stuff, it pulls in the client-server communication, it pulls in the web server. If you want, you can remove this. For example, if you don't want to have, let's say you don't need a database, let's say your app is just doing some static, is just like a visualization for static data, and you don't need a Mongo database at all. Get rid of standard app packages. Now you don't have any of them, add back in just the ones you want. But the main reason I was bringing this up was to show you auto-publish. So auto-publish is a package that's in new apps by default when you make them, and what it does is it says, take all the data that's in your database and send it to every client who asks for it. Now, that's probably not what you want to do for your actual production app. It's probably the case that not all data should be published to everyone in the world all the time. I mean, maybe if your app is basically just doing some visualizations on some public data, maybe you do. But most likely you're going to get rid of this before doing a production app. But it makes it really easy to get up and running. But when you're done with it, when you've moved past the point where auto-publish makes sense, it's pretty easy. You just remove it by doing Meteor remove auto-publish. And now if I run my app again, there's no data in it. I can type players.find.count. I'll see nothing. Well, that's a shame too. It was nice to have some data. So let's put the data back, but in a way that we have a little more control over. So we go back into the code. We go into this server section here. We can define a publisher. So we run this meteor.publish function, which runs on the server, and we say, I'm going to publish something called all the players. And when a client comes to me and asks for all of the players, what I'm going to give them back is this cursor onto the database, this query, which is players.find everything. That's the Mongo syntax. You can also just leave those out. Find everything. So when I save that, I should also mention that the Meteor tool automatically notices that I changed a file and restarts, which is pretty convenient. Don't have to and not only does it restart, it even reloads the app, but there's still no data there. Why is there no data there? Well, on the server I said, hey, if someone comes to me and asks for all the data, all the players, that I should give it to you, but no one's asking. So we can just type in the console, meteor.subscribe, all the players, and I have all my players back. That's great. Probably, of course, I didn't actually want to make the user of my app open the debugger console and type that. I probably just want to put in the client section, meteor.subscribe, all the players, which does the same thing. Now I feel like all I've done is just busy work for nothing. Okay, auto-publish used to publish my whole database. I got rid of it. Now I added back publishing my whole database. Yeah.
So this is where I got really tripped up.
Okay.
I was following this along. So how does subscribing to a named publish set in the client automatically populate sort of this global players model?
Okay. So here's how it works. I will answer you on one level, and I hope it's the level you're asking about, and if not, please answer. When the publisher here says, so I can even say literally what happens. When you run meteor.subscribe all the players, it basically sends a message to the server that says subscribe all the players. And the server says, I know what all the players means. It's defined by this function here. I'll do a query onto the players database. I will go to Mongo, I will say, tell me all the contents of players, and I will publish that across the connection. Meteor has a protocol called DDP that's sort of a stateful connection between the server and the client. I will publish that data to the client, and I will also keep publishing it as it gets changed. I'm going to keep watching this query as it gets changed. The way it gets into that player's object is through basically, there's this player's object here, right? So in the publisher here, I'm using this player's object on the server, which corresponds to the player's connection, the player's collection. The messages that get sent over the wire also use the word players because it's the name of the collection. You could make it so that the wire level collection name is not the same as the backend Mongo name if you wanted, but it's easier to not do that. The default is to not do that. Then on the client side, we also have a Meteor collection whose name is players, and when you create this collection here, it basically says, go to the connection that I have to the server and say, hey, connection to the server, if you ever hear about an object that's part of the players collection, you should give it to me. There are like options that you can pass to this constructor here. You could say, instead of going on the default connection, like, I could put it on like connection to some other server. Implicitly it's like to the default connection. But it basically, to some degree, the answer is because the collection name is part of the protocol. Did that make any sense?
Well, it does, except what happens if I publish two separate, I don't know what you call them exactly, document sets or publish sets for the same named collection? Is that possible?
Yeah.
Can that
Not only can you do that, but that's what you want to do a lot of the time. So that's actually a feature. So the assumption is if you are publishing two sets with the same collection, with the same documents, that they're probably coming from the same database too, and they probably, if any of the fields are shared, they probably have the same values. There's code to deduplicate it on the server side. But this is something you often will do, like, so maybe when you go to the front page of your site, let's say it's like it's a blog app or something, it's a blog app. When you go to the front page of your site, it shows you the list of all the posts, and the way that works, or on the left sidebar, there's always the list of all the posts, because whenever you're on any page, every page has the left sidebar, and it is listening to the, it is subscribing to a publisher that is something like, all post titles. I mean, probably it's the last 10 post titles, which returns something like, posts.find, all of them, but I only care about the title field. Right? In addition, when I go to a specific page, I need to load all the metadata I have about a post. So I'll also have another one, like, everything about one post. And publishers can take arguments, so, and this will be something like, return posts.find post ID. And so you'll always be subscribing to all post titles, but only on specific pages will you be responding to everything about one post. And the Meteor server knows that, okay, well, both of these are going to be trying to publish the title of the post you're looking at, but that's okay. I mean, there's a rule that, like, the first one to see it wins or something. I forget exactly what the rule was, but generally when you're doing this, they're both getting the data from the same place, and the data is equal anyway. But yeah, the server is smart enough to sort of deduplicate this. This is actually one of the more surprising choices of what Meteor does. I think I didn't understand it when I first saw it either. Like the fact that that the sort of document set is sort of just like a pragma. It's just sort of like asking the server, like, hey, send me this stuff. You can also return things from multiple collections, by the way. Like maybe everything on one post is going to return everything in the post collection, and then also comments.find post ID.
Yeah.
Like, so this one publisher could both show you the metadata about the posts from the post collection, but also all the comments in the comment collection that are on this post. And the idea is that we use these different document sets to create a local cache of some subset of the database, and then we use that local cache to populate our UI. Does that make sense?
Like 95% sense, but there's like a missing bit.
Sure. Well, if you still are missing that, we can come back to it later, I guess. Yeah.
So when the
No, good
client
question.
subscribes to the everything about one post,
Mhm.
it'll both in main Mongo, both the posts collection will be updated as well as the comments collection.
That's right. Yeah. Yeah. And of course this is server side code, and the client side code would look something like, I always want to respond to subscribe to all post titles, but like at a particular point in time, I will do meteor.subscribe to everything about one post with post ID, whatever. Or more likely, we'll probably use something we call auto run, which lets you say like always be subscribed, which lets you make which things you're subscribed to be reactive in the same way that we make the DOM the screen be reactive.
I guess what I don't understand is if I'm subscribing to two different publish sets that both populate my model
Mhm.
with not just one object but like a whole bunch, how do I know which set to get out in any particular part of the client. Does that make sense?
It does make sense, and I agree that this is a thing about Meteor that I would not have designed, but I'm happy it works this way now that I am actually used to playing with it. I mean, generally the way you actually write your code is there's sort of two separate things. There's code that's like construct the UI from whatever the database, from the local database, and then there's code that's like, you know, send subscribe and unsubscribe calls to ask for the data that we need, and they have to match up. You have to know which things to ask for. I mean, you know, we consider this to sort of be the API of your app. The API of your app is like the publishers and the methods that it has. But a lot of it is that it works with reactivity, right? Like, you ask for this, it brings in the data that you need, and reactivity puts it on the screen. I don't think that answered your question, though. I'm guessing.
Yeah, no, just keep
Yeah. No, this stuff is a little subtle, and it's definitely a little surprising that like when you get data from the server, it's not tagged with like this is the subscription it came from.
right. That's what I don't get.
Yeah. There's also like you can make publishers that just run all the time. You can say meteor.publish, like, you know, this without a string, and then whatever it publishes, like, it gets sent down to every app. Yeah. I find that it works really well in practice, even though it is not how I would have designed it. Like, but I probably would have designed a lot of this stuff. I'm happy that someone else did. I guess I've designed some of this stuff, but let's see the bottom of the string. Oh, there's nothing there anyway. Okay, so let's see. Back to this. The one other thing I wanted to show was, so this is how you control exactly what data is being published. So right. So right now I haven't really won anything over using auto-publish, right? I've started with publishing everything, then I got rid of publish everything, and I came back and said publish everything again. And, you know, we published these 6 scientists. But the point is, this doesn't have to be just publish everything, which is what I was showing you there. So we could say, for example, let's actually say all the players is like all the players except for Tesla. You know, Tesla is secret, that the user should not know that Tesla is in here. So we save that, and now we're no longer publishing the Tesla thing. So you can use the publishers to control who can read what, essentially, and also to not overwhelm your servers and your clients with here's every piece of data in your database, which obviously does not really scale to most apps. And one other thing that I like about Meteor is the Meteor deploy command. So I built this app, I'm running it locally. Now how do I run it in production? There's 2 answers to that. One answer is Meteor deploy. So I type Meteor deploy, hello Chicago. And I type that. I guess there's one thing I need the internet for in this talk, but I did get it to work. So it says deploying. I wait a few moments. See how long a few moments is? Well, while it's doing this, I'll tell you the other way. The other way you can deploy your app is you run Meteor Bundle. It gives you a tarball with basically everything you need to run the app other than a copy of Node, the Node server. You put it on whatever Linux machine or whatever server you want, and you run the bundle. And you don't need to be, and that is actually what, you know, most people are using to run their Meteor apps today, because while this thing that I'm going to show you is pretty cool, now I can just go to hellochicago.meteor.com and I have this app, and so does anyone else in the room, which I think is really basically the simplest deployment that like any app framework has anywhere. I mean, I made an app, I typed 3 words, now it's on the internet. It's on the internet on a server that doesn't have any SLA, and that we mostly recommend you use for testing and for testing and playing around with it. But where we're going from that is a little later in this talk. All right, so that's the other thing I wanted to show you is deploy. We think that it's important not just to make it easy to write apps, but also to be able to deploy them in production. So back to the presentation. So everything I've shown you so far existed, in April 2012 when Meteor was originally released. I want to talk a little bit about what I've seen happen though over the past year. So what's the difference between Meteor today and Meteor a year and a half ago? So I started at Meteor a year ago. I had been working at Google in developer infrastructure for about 5 years, and I quit that job to go work at Meteor to help make Meteor a thing. And so so I'm just going to give a list of things that we've done in the past year. Not exhaustive, just things that I think might be interesting. So the first one's actually a relatively small thing, but I want to say it because it's my first project. Make it so your Meteor app can send email. Now this isn't that exciting. Okay, there's a API, email.send, you add it, you can send email. I mean, it's not that much code. It's basically a wrapper around the pre-existing email thing. It was a little exciting to me because after working at Google on a project that took 4.5 years to launch, I was releasing a feature within the first week of my new job, which was pretty cool. But you know, it wasn't that much code in the Meteor itself. The thing I really liked about this feature, though, that was exciting is, so how do you actually send email? Okay, well, you write some code that speaks SMTP, or that hopefully wraps somebody else's code that speaks SMTP, or some other thing. But then you actually need a mail server. And so if you're using Meteor Bundle, where you get a tarball and you put it on your own server or in an AWS or whatever, and you run it, then it's pretty simple. If you want to send email, you have to configure it. You get a mail server somewhere, you get credentials to log into it, you set the URL to it in an environment variable, you set that when you run the server, it works great. What if you just type Meteor Deploy though? So we actually set things up in the Meteor Deploy server so that that there's zero configuration needed in order to send email with Meteor Deploy. So every time you add an app on Meteor.com, it actually gets a free account with a Mailgun, and you can send 200 emails a day. I mean, it's not infinite emails. We don't want to be making a spam bot army here, but you at least get enough to start playing around with apps that write emails that send emails with zero configuration needed. And that's just sort of an example of how we actually think that like controlling, like having a single framework or a single platform that is server and client, and then even can integrate with a deployment side, can make things easier for you to write apps in. But this is just a tiny little project. Let's talk about a big project. So, big project, Meteor accounts. If you saw the first Meteor screencast in April 2012, you might have said, huh, so anyone can just open the JavaScript console and like write to my data? And in fact, for the first 6 months of Meteor, basically anytime anyone had a blog post about Meteor or whatever, it would be full of comments saying, wow, these folks are idiots. They have no security. Anyone in the world can read all the data and write all the data. And while this was not 100% true, like you could turn off auto-publish and control what data is readable in the way I just showed you, there still wasn't a good way to control what could be read, because you still had to have some way of deciding, who's logged in to let you know, that, in order to decide who can read a thing, you have to have an idea of who the person is in the first place. But for the first 6 months, it was pretty true that we had no actual security in Meteor in that sense. Not because we're idiots, as we try to tell people, or try to just not tell people and let people talk among themselves, but because we didn't want to do a crappy half-assed job when we could do a full-featured job. So back in last October, I worked on this a little. This was the first big thing that came out after I started, but I didn't work too much on it. Meteor accounts. We released Meteor accounts, which is a full-featured auth system. So what does full-featured auth mean? Well, first of all, it does give you the data control that I was talking about before. It lets you take your publishers and your methods and your collections and say, these users, based on a user ID or a user document, are allowed to do these reads, these users are allowed to do these writes, these users are allowed to write these methods in a pretty easy to do way. But it also said, well, how do you log in the first place? Well, we implemented a couple of versions of login. We implemented federated OAuth login, so log in with your Facebook account or your Twitter account or so on. We implemented password login using the SRP protocol. And when I say password login, I don't just mean like you can log in with a password. I mean password login, user creation, email validation, password recovery, password change, all the things you want for a basic app that has passwords. And we didn't just add APIs for that to add to your own UI, which we did add. I mean, we did do that. We also added these optional UI widgets so that if all you just want is, look, I just want to be able to log into this app. I don't want to spend like my first day of my Meteor app building a login screen. Well, let me just show you. This will be maybe the last demo, but pretty simple. Okay, Meteor add accounts UI. Simple templates to add login widgets to an app. I'll run the app again, and I'll go to the HTML, and I'll add just to the top of the page, I will type this one word, login buttons, plus some punctuation. And what do I get? Well, I have to go back to the one that's running here. I get the words, no login services configured. Okay, well that's true. All right, let's kill that. Let's add accounts password. And wait for that to reload. It reloads faster when it's just updating in place. That takes a moment to notice. Okay, so, oh no, now I have a little sign-in form. I can sign in with, well, I don't have anything to sign in, so I'll create an account, email, then some random password, create account. Oh, now I'm logged in. I can even change my password if I wanted, and sign out. You can configure it to be a username instead of an email if you want, or you can configure it to allow both. So forgot password form, etc. And that was just two commands at the command line. Not only has stable APIs, but those stable APIs include how to write packages. We think it's great that we've gotten this far with Atmosphere. I mean, as I said, I think I checked a couple days, like yesterday, we had 582 packages. Even given the fact that until like a month ago, there was literally no documentation about how to write a package. And even now, there's no like good, we only have sort of, like our documentation is still mostly like, well, look at a package and then this is the file that matters, just look at it and copy it, and here's a couple advice. And that, even that we only added like literally a month ago. I mean, I'm not saying I'm proud of that. I mean, I think we should have better docs. I mean, we put a lot of thought into the docs that we do write, and when we don't document something, it's mostly because we don't want to write terrible docs. But yeah, we're pretty happy with the fact that there's over 500 packages when we didn't even tell anyone how to do it. So we expect there to be even more and higher quality and stabler because they have the correct versioning directives packaging once we actually have this be something that comes with Meteor, not an external tool. And we know that the folks who made Atmosphere are looking forward to the day where they can retire where their tools get retired. I'm sure there will be plenty of credits on the Atmosphere page to the former version, because we really appreciate that. So those are the main things that we're looking for before 1.0. Third-party packages, better Mongo scaling, a better version of Meteor Deploy, and this UI and a rendering engine that like actually works with your jQuery plugins and any other stuff you want to do. So we're hoping to get to 1.0 soon. I think we're not necessarily saying a date now, but early next year is our hope. We want 1.0 to be a release we can feel comfortable supporting for a while. We want to stop this thing where all we're doing is rewriting things over and over and breaking everybody's app all the time. Like honestly, right now, if someone says I want to write a Meteor app for like myself, for my friends, for my internal tool in my company, whatever, I say that's great. And when someone says, we want to start our startup and launch it on top of Meteor, I say, okay. Or when they say we've written a Meteor app and we're about to launch it, I say, okay, and you've load tested it, right? But I am really looking forward to the day that I have the same answer to the question of should I be using Meteor for my startup, trying to to have a website used by thousands of millions of people, that I do for people saying, hey, I want to make a tool to like organize my life or my my group of my organization that's trying to get something done. We'd love to get there as soon as we can. Some of that will be through pull requests, but a lot of that will be us doing it. So we are hiring. Admittedly, we are currently only hiring in San Francisco, though. We want to get to the point where we think we can do remote distributed offices, but distributed work, but not yet. Yeah.
I've seen a great remote code pair programming app written on top of Meteor. So
Oh yeah, it's true. Yeah, the what's that one called? Mad Eye or whatever.
Yeah.
Actually, there was like a dev shop where there were like 3 different like pair programming apps demoed in the lightning talks. It was pretty cool. The thing is, I mean, I think there will be a day where we have a lot more work that isn't like, okay, we need to rewrite this piece of the thing. Let's like get in a room and brainstorm for the day. We do a lot of we're still at the sort of fast-moving change, break things all the time pace, and we unfortunately especially unfortunately because we just like, well, I'm being taped, so I'm not going to talk about our.
You can switch it off.
What, it turned off?
Alright.
No, this week. Let's just put it that way. Yeah. So, any questions about?
Do you think 1.0 will come before New Year's or after New Year's?
I would say it would have. I mean, I think we'll have our goal right now. The date that we told our board at our board meeting yesterday was a date that was after New Year's, and I hope it, but not super far after New Year's. I think my personal goal is that by New Year's we have announced a date, or a date that we're aiming for, because I mean, look, 1.0 isn't going to be like, okay, we just finished implementing this thing, let's push it out right now. It's going to be, okay, now let's do like a review and make sure that we're not forgetting something huge that we like forgot to do, and let's make sure we get all the docs better. Let's make sure we get like our website better. There's gonna be a lot of non-technical work, so I think we'll have a pretty good able to predict at least a few months off. Yeah.
How about web components in the future? Like client-side templating,
that's not using JavaScript?
Oh yeah, like the template, the template is my HTML gang sign. The template HTML thing. Yeah, I don't know too much about that. I know the folks who are working on that. That's like mostly like at Google, right? The folks who are working on that, and David Greenspan, who's our sort of front end wizard, as I said, the guy who did Etherpad. Like right when they first put out that RFC, they actually like contacted us, and I know they're talking. My guess is that we're going to keep an eye on that. I'm not super convinced that it's going to be like the most. I'm more of a back-end person myself anyway, but my impression is we're not super convinced that this is going to be like the way and the light for everything, at least like anytime really soon, but we're definitely like in touch with those folks, and it does seem pretty interesting. Yeah.
We wanted to swap out the authentication package,
Mhm.
because that's what my company does, and we wanted to build a package for that.
Mhm.
How deep does that go? Is that?
So it's designed in layers. So for example, in the package that implements our like protocol, or like client server protocol, is called Live Data, although we don't refer to it as that other than the package name, and we should probably rename it to DDP or something. But in that package, the concept of being logged in or logged out is actually very, very simple. Like there is a user ID associated with a connection, and you can write your own methods that set, any method you write can set the user ID, like on the server, and there's, but like, and methods and publishers can ask what the user ID is, and like that's it. There's not even like any data associated with a user other than a string that's a user ID. And that's all that's in the very low level version. Then there's like the accounts base package, which adds like the meteor.users collection, the idea that this user ID string is actually an ID to a Mongo collection storing information about users, and the idea about like having login methods that set the user ID and a standard flow for writing login methods that actually works well with with Reconnect and all sorts of things. But that's a second layer on top of that. And then the OAuth stuff is a layer on top of that, as is passwords. There's sort of like a tree you can draw. But yeah, we tried to keep it we tried to make it so that if you wanted to have, methods and publishers that care about the user, but that user is not a primary key into a Mongo, into a Mongo database, and the user is not set up through this password login or this OAuth login or whatever, that you could rip all of that out. Or on the other hand, if you like the Mongo database, but you just don't like OAuth or password, that you could, at least in theory, put in your own login handlers for that. Like for a very simple thing, like I use this for I made a Meteor app for like a group of friends to organize our knowledge when we were doing this puzzle event together. And I wanted to have a password you had to type in order to log in, and I wanted to be able to have to like log in to put a username so it knew who was using it, but I didn't want like everybody to have to remember a password just for one weekend. That wasn't just a password where we could write on a chalkboard. So I wrote my own handlers where there's like one login thing that's just you log in by typing the global password or not, and then once you're logged in using the global password, you can log in as a user just by choosing its name. And so all that was actually pretty easy to write once I refactored some of the APIs to make it easier to write. But now anyone can hopefully do things like that. So yeah, we tried to keep it as designed to add like separable layers as possible.
Okay, sounds good.
Yeah.
So how
Yeah.
far does the latency compensation take you? For instance, if you're offline for 10 minutes
Mhm.
and you do like 6 or 7 state changes and then you go back online, will they all be played back? Or
Yeah, I mean, yes. Now, I mean, it might be that your version of the world has moved far from the server's version, and several things you've done might not be right. So the way latency compensation works essentially is I haven't really shown you methods at all, but basically DDP has two things. It has data you can subscribe to, this publish and subscribe I showed you, and it has methods. You can define RPCs and call them. But a thing that it has that most things don't have is, in addition to defining method bodies like the RPC body on the server, you can also define the method body on the client. And in fact, because you can put the same JavaScript file to be run in both the client and the server, you could actually have it literally be the same code physically, like the same file with the code running on the server and the client. And so when you call a method on the client, what it does is it does two things at once. One thing it does is it sends over the network a message that says, hey server, run this method for me, and the server starts running the method and returns the result and does stuff, etc. And at the same time on the client, if there's what we call a stub, which is sort of the client's version of the method, it runs the code on the client, which might And so, for example, if this is a method that does a write to a database, like inserts a comment, on the server, it'll actually insert the comment. On the client, it'll just insert the comment into the local cache. And it does it in, it knows that it's in a stub while it's doing this, so any changes that are made during the stub basically get reverted once the method is, once the server's done running the method, and in a way that it's a little complex. I could do a whole talk just on that, but the idea is you don't have to keep track of this yourself. Any changes you make in the stub will get reverted, but hopefully, you know, a lot of the time they're the same change that the server's made, or maybe it's a fraction of the change. Like on the client, it inserts the comment, but it also sets like a flag that says it's not really there yet, which allows you to put it in a different color, and then when you get back to the server, it doesn't have that flag, so it just changes the color, but it doesn't like redraw the whole screen. And we put a lot of effort into making it so that what you don't see is the thing gets inserted, then you hear back from the server, then the thing goes away, and then it comes back. We put a lot of effort into trying to get rid of flicker, which I don't know how you can do without, again, like a protocol that has the things you need to do this, and basically having the server and the client think the same way.
Is there a time sync or anything like that?
What do you mean?
A time sync?
Oh, for just like timestamps synchronization, like NTP? No, we haven't.
In this case, like you were saying, you're offline for 5 minutes because you lost your connection or something, now you got it back.
There's a verb.
Well, I'm just trying to see if you could use
Yeah.
this for building an offline aware
Offline.
web
So
application.
this isn't, what we have in core right now is not itself great at doing offline aware stuff. Now there are people who've been building Atmosphere packages that, including Andrew who did the app cache thing, then someone else, I think, what's it called? I haven't actually had a chance to look into it. I think it's called GroundDB or something, that uses like browser side cache stuff to give you more persistent offline storage for that, and gives you better conflict resolution when things change. I haven't had a chance to look into that myself, but it's pretty cool.
So in most cases, you shouldn't need to because no one else is going to change that. I mean, maybe you're the
Yeah.
only authorized.
Yeah, I think right now we're not really aiming at the offline use case so much as but we certainly are aiming at the flaky connection use case. We put a lot of thought into how reconnect works and how you can tell if you got disconnected, and when it reconnects, it tries to get back to the same state. Yeah.
Is there any point in controlling, like turning off a user's connection to save resources, or are you just kind of treating it like?
On the server side, like if like kicking the user if they're being bad or something, or
Your subscription.
Stopping the subscription, probably stopping it from the client side. Is that something that you?
well, yes, I mean clients can unsubscribe when they don't need anything anymore.
Okay.
Yeah, the subscription, when you call meter subscribe, it actually returns an object that has like a stop method on it.
Okay.
Yeah, you can do that. Also, one of the things we did as part of Bug Week this week is we decided to delete a whole bunch of code that's like, so when you do, as I said, we do have reconnect, so we make sure that the client works properly when it gets disconnected and reconnected. In theory, what we'd want to happen is to have like the client able to just reconnect to the server and say, hey server, you remember me? Like you remember what data you already sent me? Like that's me, I know that stuff. Actually, we didn't 100% we need in the protocol to like make sure that they're precisely synchronized enough to make this safe. So actually what happens is it just gets a brand new connection, and there's client-side logic to make the reconnect look smooth and not look like everything disappears and comes back. But we had all this stuff in the server to like around the idea that we might eventually implement session resumption, which we will at some point. But what I mean by that is like when you disconnect, it waited 2 minutes before cleaning up your state, and like we decided this week just to delete all that stuff, which is great because it seems kind of silly for the server to do a lot of work for clients that aren't connected, just because maybe in the future we'll write code to be able to make that work be useful. So we deleted that this week, which is great. Also, we fixed an infinite loop bug that we found, which is the impetus. It was a pretty funny bug. It was, but it's. Yeah, we don't. I'll just tell you, don't like write code that tries to like clean up things by doing like my in queue. It's like, okay, I'm tearing down my connection, so I need to clear my queue of incoming messages and my queue of outgoing messages. Don't write the code like this, because what this does is it means that if you ever start using it again, and then you start that your in queue and your out queue are actually the same object, and so the server would talk to itself, and it would just send itself an infinite loop of. It would basically literally just send itself a message saying like, I don't recognize that an error message saying I don't recognize that message, and then it would send it, and then it wouldn't recognize that message either because it's. Anyway, this only happened under really obscure circumstances, but we decided to delete all of the code that was related to that this week, and now your server doesn't do stuff in the background for no reason. So Yeah, that took a while to find, but yeah. Yeah, anything else?
So reactive forms will be in Meteor UI, that's sort of the old,
That's a good question. So right now, yeah. So how so like components and like forms that one thing we tend to do is we have a project and it has a lot of goals, and then we finish the first goal and we release that, and then we keep working on the next one. So I think the first release we're making for Meteor UI is actually going to be mostly backwards compatible, and it's mostly going to be based on the idea of replacing like Spark, which is the render by rendering two things and patching it in, with the more precise like just update the right thing because we actually understand how to parse HTML. The next step after that is building. We have a work in progress that is less close to release. That's sort of this components and template stuff. And on our current like what we think 1.0 list is, that's the one thing that's actually of the form like, well, if it gets done before 1.0, great. If it gets done after 1.0, also great. Which is mostly just like actually a human thing. Like it's literally like, like this is the thing that, David Greenspan is really good at making this stuff, and he's really good at doing everything, but he's really good at doing this stuff, and we're just going to have him and whoever wants to work with him keep working on this, and if that part gets done before 1.0, great, it's a part of 1.0, and if not, it'll probably be 1.1, but like that is much more better than us being like, David, you need to like stop doing this crazy awesome stuff that you're uniquely good at and just like work on something like else just to get us to 1.0. Yeah, so I hope it comes sooner rather than later, but it'll get there. The current release is sort of baby steps towards that. Anything else? Cool. Well, thanks for having me here.
Thank you.